Okay guys, hello. Today we are looking at the problem, why did the cow cross the road 3? So let's start. Farmer John is in his old age has unfortunately become increasingly grumpy and paranoid. Forgetting the extent to which both feed and diversity help his farm truly flourish over the years, he has recently decided to build a huge fence around the farm. That's bad, discouraging cows from neighboring farms from visiting, and completely prohibiting entry from a handful of neighboring farms. The cows are quite upset by this state of affairs, not only since they can no longer visit with their friends, but since it has caused them to cancel participation in the IMO, an event to which they look forward all year. Neighboring cows can still have the ability to enter Farmer John's property, find the process has become more arduous, as they can enter only through a single gate, where each cow is subject to intense questioning, often causing the cows to queue up in a long line. For each of the N cows visiting the farm, you are told the time she arrived at the gate and the duration of time required for her to answer her entry questions. Only one cow can be undergoing questioning at any given time, so if many cows arrive near the same time, they'll likely need to wait in line to be preceded one by one. Alright, so here's an example. For example, if a cow arrives at time 5 and answers questions for 7 units of time, another cow arriving at time 8 will need to wait until time 12 to start answering questions herself. Please determine the earliest possible time by which all cows are able to enter the farm. So over here we have the input format. The first line of input contains n, a positive integer at most 100. Each of the next n lines describes one cow, giving the time it arrives and the time it requires for questioning. Each of these numbers are positive integers at most 1 million. So for output format, please determine the minimum possible time at which the cows could have completed processing. So you can see here's the sample input and here's the sample output. Here, first cow arrives at time 2 and is quickly processed. The gate remains briefly idle until the third cow arrives at time 5 and begins processing. The second cow then arrives at time 8 and waits until time 5 plus 7 equals 12 to start answering questions, finishing at time 12 plus 3 equals 15. Alright, so over here we have a list. We have this visualization. So this is all the units of time from time 1 to time 17. And over here we have the waiting list. Over here we have the questioning list. And we can see that from the data is 2, 1. So at time 2, one cow arrives, and his questioning time is 1 second, which means by time 3, this cow 1 we'll name, has already finished processing. And then at time 8, one cow arrives. They need 3 units of questioning time. Lastly, at time 5, a cow arrives, but there's 7 units of questioning time, which means that over here, after cow 3 has started questioning, cow 2 arrives. So cow 2 will likely have to wait. It have to wait for 5 units, and then it could be questioned. And we add everything together, the total time is 15. So one important aspect is, one important thing we need to understand over here is there are 2 cases. One case is when a cow arrives when Farmer John is ready for inspection. In that case, the total time is now the cow's arrival time plus inspection time. If, for example, there's a cow which arrived when another cow is being questioned, oopsie. So if one cow arrived when another cow is being questioned, then that the total time is the last cow's total time plus the questioning time of a new cow. So over here, let's just switch to VS Code and let's see the code I wrote. So class cow, def init self arrival time, questioning time int. So this is an initialization. This is an initialization of a class cow. So it has 3 terms: self, which is a universal term; arrival time, which is the time the cow arrives at the farm; and questioning time, which is the length of time that Farmer John questions the cow for. Alright, so let's redefine this, and over here we say class farm gate queue. This queue This queue has two values. One is current time, which is time when the gate is available, and this one is queue, which is list to store cows. This is unused in this solution, but this could be used in other future solutions. Alright, so now let's write a function under class farm get queue. So this function is called def process cow. There's a self, there's a cow, and the type of this is a cow value. Alright, so the function of this is to process the cow and return the time it finishes. The parameter cow means the cow being processed. The return means the time the cow finishes processing. So let's first update current time. If the cow arrives later, if current time smaller than cow arrival time, current time equals cow arrival time. And after that, we're going to add questioning time to the current time. If that is not the case. Alright, so this is a solving function. We read the input, we strip the data, we write a list, and then we read each cow's arrival and questioning time and input that into the function. Lastly, we will sort the cows by arrival time. We'll create queue to process cows. We'll process all the cows and get the finish time of the last cow. And after that, we will write the result to cow queue.out. Oopsie. Oops, yeah, where did I open it? Where is it? Interesting. Oh, okay. So let's just quickly run this real quick and let's see. The answer is 15. What is the correct answer? It's also 15. So that's the correct answer. Thank you for watching.